after studying the vector, dealing with the vectors, we'll learn about the linear equations, which are another important thing to as a basis of machine learning course. So linear equations are equations of the form y equal to mx plus b, where which creates a straight line when you plot it on a xy plane. Okay, so for multiple values of x, y will have different values, and that's why you will have a straight line which will satisfy for different values of x. Like here for x1, you have a point on this line which is y1. Here for a value x2, you can have another value y2. But then what is m here? M is considered the slope. Okay, so like here x1 and y1, x2 and y2. So y1 increases because increase in x1. So whenever we try to calculate how much y value changes for unit change in value of x, so we call it a slope, y2 minus y1 divided by x2 minus x1, or also represent m equal to y over x. Okay, so now what is b? So if we make x equal to 0 in this equation, we'll find that y equal to b, which we call intercept. Okay, so in this equation, y equal to mx plus b, which is equation of a line, b is the intercept and m is the slope, and they are very important parts. Okay, so now once we talked about one equation, we can talk about multiple equations, which are called systems of linear equations. So here there are two equations and two unknowns. So like x1 and x2 are the variables whose value we do not know, and then these are the coefficients. So y1 equal to m1 x1 plus m2 x2. It's a linear combination of different variables. Like there we had just one variable x, here we have two variables. Similarly, this is another equation, y2 equal to w1 x1 plus w2 x2, where w1 and w2 are the slope of this associated with the variables. So now you see, because there are two variables, we need two equations to solve it. So what does it mean, solving? So solving the equation means basically we are trying to see whether the equation that these two lines are parallel to each other, or they are representing the same line, or they are intersecting with each other. Okay, so if they intersect with each other, if their two lines are intersecting in a two-dimensional plane, then we'll have one particular solutions. Okay, but if they are parallel to each other, then they will have no solution because they are not intersecting, and the system will be called inconsistent. That means they have no solution. But another case is possible where they are representing the same equation, same line. In that case, there can be infinite solution. That means for different values of x, there will be value of y corresponding. And in that way, there can be infinite solution. I've given some example of parallel line, like this two red ones, x plus 2y equal to 1 and 2x plus 4y equal to 1. They are parallel to each other. Okay, they are parallel lines. But x plus 2y equal to 1 and 2x plus 4y equal to 2, when I just multiply them with 2, each variable, then you will see that these are basically the same line. Okay, these are basically the same line. So whatever value of x, the first one will satisfy the similar one, the second one will also satisfy. Here, now from there, let's move on one more level where we are dealing with three equations involving three variables. Okay, so when there are three variables like x, y, and z, so this is this represents a plane, not a line, just because this one was representing a line, but this one with three variables will represent a plane. Okay, so something like you can see that a1x, a2y, a3z equal to b1. So where b is the intercept, and a1, a2, these are the coefficients, and x, y, z are the variables, and we usually write them one after another in the same row column format, and you will see that because they are represented using a plane, so they can have also, like with the equation of two variables, we can have the solution concept. There also we have a solution concept. So here the solution can be infinite, and they can they can meet at one point, the three planes. They can meet at one line. They can meet at a plane. So multiple things are possible. Let's see here. This red one is a plane, which is equation involving x, y, and z. This one, and green one is another plane involving three coordinates x, y, and z. But the blue one is a line where a1 x and a2y are there, but no corresponding z variable is there. So in that case, there will be not the third dimension, which will only be a line. So they will meet at a particular point. And you can see this is an example just to visualize the concept. You see that two planes of a room, two, let's say two walls, they meet at a line. When there are higher dimensional higher dimensional items meet at a lower dimension. Two planes meet at a line. Two lines meet at a point. Similarly, two three-dimensional plane, room will meet at a plane. Okay, so three-dimensional meet in two-dimension, two-dimensional meet in one dimension. In that way, it works. So here you see that if you consider three planes, this is one wall, this is another wall of a room, and this is the floor. They actually meet. All the three will just meet at this one point. Okay, so this is a common point. It's a corner in a room. This is the idea of, as I said, if the three planes are parallel to each other, they will not meet with each other and there will be no solution possible.